Let's get to the next chapter, sectional views. So let's see what we are going to see in this chapter. The objectives are: what are sectional views? Why do we draw sectional views? Sections and cutting plane lines. Hidden lines in sectional views. Lines behind the cutting plane. We're going to see what the sectional lining practices, techniques, and symbols for sections are. Then we will draw a sectional view when an isometric view of the object is given. Placement of sectional views. We'll talk about the line precedence. Sectional views in 3D. And finally, we are going to look into all the different types of sectional views there are. Now, starting with the first one, what are sectional views? Sectional views are orthographic views, just like your top view, front view, side view. It's one of those orthographic views that are used by the designer to show features that are hidden. Okay, so that's the reason why we draw sectional views. Now, for example, if I'm looking at this isometric right here, and I would like to make a section or cut this object right from the center of these holes so that I get the exact sizes of the circles or holes, and I know what type of a hole is this. Is that a hole going through and through? Is that a counterbore? Is that a countersink? So sectional views is the best way to show that. Now, another reason, for example, would be you have I would say a watermelon, and you want to see what is inside of the watermelon. Now, if I'm making a drawing for the watermelon, the front view would look something like that, and you have those lines that go on the watermelon. Okay, so that's something like what a watermelon looks like. Now, this is the front view. Now, if I want to make the top view of the watermelon, it looks something like that, right? It pretty much looks something like the front, but the lines are gonna go from the center for the watermelon. Then you can have a side view, which pretty much will look like a front view, but I don't know what's going on inside. So for that, what I would have to do is cut the watermelon right from the center and see what is on the inside. So if I draw, now this is my section where I'm going to use a knife to cut the watermelon right from the center. And I'm going to look in this direction, just like the arrow shows over here. Now, if I want to draw an isometric view, the watermelon from inside would look something like this. And now all you have in here is the seeds. Now, there was no way to show what was inside other than cutting this watermelon right from the center and showing what's on the inside. Right? So that's the primary reason why we draw sectional views. Now, for example, if I have an object that looks like a block right here, concrete block is hollow in the middle, and I have the orthographic views, which is the top view and the front view. So what I need to do is see what's on the inside of this block. Is the hole going through and through, or is there something? Now what I see over here in the top view is there is this circle over here. So there's something happening. There's a hole over here. So how do I show that? So for that, what I do is I cut the block right from the center, going through the hole and going all the way, and then I'll be looking in a certain direction. So if you look at the top view, what you see over here is this thickness, and there is a circle, which is a hole right there. But I don't know where the hole is. Is it starting from the top? Mostly not, because I don't see it over here. So the hole is at the bottom, and the only way I could show it in here is by drawing a section. So if you look in this drawing, I'm cutting through this concrete block, which is this section. I'm cutting through this solid block, which is this section, and then I'm going all the way down, and looks like this block keeps extending right here, and then there is a hole right in the middle, which is this hole. So that way I could show in the section where the hole is. So when it comes to orthographic projections, wherever we have holes, or as well as wherever we have a lot of hidden lines, then we need to make a section. What a section is doing over here is it is getting rid of the hidden lines. For example, instead of having a section over here, if I had a front view of the same object, it would look like, it would pretty much just look like this. But then we add our hidden lines to make the object more clear. And when we add our hidden lines are going to go like this. And there is a hidden line for the circle. But what's happening over here is the hidden line doesn't explain it really clearly. That's the reason why I am drawing the section view. Now, one important thing that the section view does is it eliminates the hidden lines. And that is why we are using sectional views as an extra drawing or an extra orthographic projection. So in this case, the front view, if I would have just drawn this, it doesn't help me that much. But instead of the front view, if I had the section view drawn there, then it explains the object more clearly. So that is one of the examples that you saw. Then we saw the watermelon, how we cut it, and what we see on the inside. Let's see another example when we look at this object right here. So now what this object shows is it shows some holes and just an object that looks like an L shape. Now, as I told before, we are going to take sections going through the holes as much as possible, and the main reason behind that is we need to avoid these hidden lines over here. So I have a top view which looks like this, where this one corresponds to this, the second level corresponds to this one, and the third level corresponds to this one. Then this part, this base of the L, is what you see over here, and we have 1, 2, and 3 holes, which are 1, 2, and 3. So I have my top view, and I have my side view, and I had my front view. But what happens if I had a front view over here instead of a section view that you see? I would have a lot of hidden lines like that, and that would confuse someone. So that's the reason why I will make a section. Now where do I make a section from? Section from going right through the center. So if you would look, I would be cutting this right through the center from here, and looking in this direction. Okay, so that's where I will be taking my section AA. Now how do we draw this section right here? It's really easy. As far as I have my top view, which is really easy to draw, all I do is project my edges all the way down and draw my front view. So if I were to draw a front view and I project all my lines down, my front view would look like this. Another thing I'm missing over here is this level, so I would be doing that. So this pretty much is my front view, which really doesn't explain much. I can throw some hidden lines for the circle if I wanted. There's one circle, there's the second circle, and this is the third circle. I can draw the center lines, center line, and center line for the circle. But again, as I said, this gets really confusing. So instead of giving my front view, all I do is give a sectional view. And it again is pretty much the same, but I need to hatch wherever I cut through the object. So if you look over here, I'm cutting through the object from here to here, here to here, here to here, and here to here. And once I cut that, I'm just going to hatch it, which with hatch lines, that shows that I'm cutting through the object. So see, now this one makes a lot more sense than if I would just have a front elevation that looks like this. So what I'll do is just get rid of this one because I really don't need it. Now what we are going to look into is, we saw what sectional views are. Why do we draw the sectional views? In the end, we are going to see all the different types of sectional views there are. We have full sections, half sections, offset sections, broken out sections, aligned sections, revolved sections, and removed sections. So we are going to see how to draw all of this in the next hour or so. Now we even saw hidden lines in sectional views. Now the main reason why we are drawing sectional views is to get rid of these hidden lines. Okay, so you will avoid to show hidden lines in your sectional views, because that's the main reason we are doing, is to get rid of these hidden lines so we can see or understand the object more clearly. Now, the next thing is what is a cutting plane. So cutting plane is pretty much what you see over here. It's a plane that cuts the object. Another easier example to see a cutting plane is right here. Like if I have this object and I want to cut it in half, so that would be called as a cutting plane. So I would cut the object right from that plane. Okay, so in this case, this is our cutting plane, and over here our cutting plane line is right there. In here we have our cutting plane line going like this. Now there are different ways and different types of cutting plane lines that we can have, and basically there are two cutting plane lines that are drawn in our sections. One of them would look like what you have over here, with showing an arrow, and I have lines that go like a hidden line pretty much, but it is at an equidistance. Now this line is a hard, heavy line. It is not the light type of a line that you would have, because it's one of the most important things in your sectional view is showing the sectional cutting plane. Because if someone wants to know where the section is, he's just going to look at that and he know, okay, I already have a section view somewhere in this drawing. And he's just going to go directly to that to understand the object more clearly. Now the second type of a line that you could use either one of these. The second type of line would look like one, and then I have 1 and 2, and then I go for the next one, again the long one, then 1 and 2, the short ones, then I go for a long one again, and that would be my cutting plane line. Okay, so two different types, you could use either one of those. Now sometimes what happens in a case like this, you even want to show the center lines for the circles. If the cutting plane line and center line for the circle are on top of each other and are getting confused with the drawing, so what you could do is, instead of having the cutting plane going all the way through, I could just end it up right there. So I could so all I had to do is just go right there and cut it out, and go right here and cut it out, and this would be the center line for my circles. Sometimes the center line is just a little X, sometimes you want to take it all the way, so it's up to you. But you could show your section going just like this, and it is still understood that this is where the section was taken from. The next thing we have to remember is we have to name our section. So I might have two sections on the same object. One is going in this direction, and I could have the other one going in this direction. Again, both of them are going through the hole. Not this way. Okay, so if I already have BB, I can call this as AA or CC. Okay, and this will be placed somewhere on my sheet, and most probably it will be placed on this side. Now again, these are standards and rules that we need to follow while drawing sectional views. For example, I made a section over here called it BB. I cannot put this section view on top of here. I have to put in the opposite direction. I have to place it in the opposite direction of where my arrows are pointed. So in this case, my arrows are pointing right there. So the placement of my view should be right here, is in the opposite direction. It cannot be placed over here. So this is wrong. Okay, so it has to be placed in the opposite direction, which is right here. Now, if you look for some more examples, I did the watermelon over here. I have my cutting plane line. And if you look, my sectional view should have been placed over here. If I place it over here and call it section AA, it is not a good practice. So it has to be placed right in the opposite direction of where you had the arrows. So for example, I have another section right here, and if you see, it's placed in the opposite direction. If you look at this one, again placed in the opposite direction. Now see, if I have a section going like that, my view is placed in the opposite direction. So this is the right one. So I couldn't have this placed in here. That would be totally wrong and against the sectional view practices. Okay, so this is wrong. Got it? Okay, so that's all about cutting plane lines and what are the standards of cutting plane lines. How do we draw a cutting plane line? In this case, both of them are correct. Okay, how do we name the cutting planes? Can call it A. Sometimes it's even called B dash. Okay, as far as you name it correctly, that's all that is needed. So if I have B dash over here, B dash over here, then even this should be B dash. Okay, so this was the cutting plane. Another thing we have to look into is lines behind the cutting plane. Now let's look at one of the examples over here. Now when I am cutting this object, we already saw this example. I see it's cutting through this area, is cutting through this area, right? And underneath, which we cannot see right now, is going through like that. But what is this line? Why do we draw this line? So if you see this line, it's pretty much that edge that you see over here. Are we cutting through this? No. So this is an elevational line of the object. Do we omit that? No. We have to show the object lines that are behind the cutting plane. Okay, now let's see another example. Now when I'm cutting through here, I'm looking in this direction, right? Because you see the arrow? So I'm seeing this, and this, which is this surface right here. 1, 2, and 3. is basically this surface. Okay, so it's basically just one surface, not three. But when we are looking in that direction, we have to make sure that we project these lines because we see them. So I'm seeing this edge, this, going all the way down like that. Okay, so don't forget that. So those are the lines behind the cutting planes, also called as the object lines. Now I could show you another example. Is right here. Now I have taken this section right from the center, from the hole. If you looking in that direction, so obviously I have to have my section view drawn right here, which is a good thing. I cannot draw it on the top because it has to be on the other side of the arrows. Now what am I cutting through here? I'm only cutting through this part, if you can see. Okay, or in the 3D view, I'm cutting through right here. And obviously the cylinder on this side. So that's what you see my hatch over here. Well, why don't I see a hatch on this side? The reason why I don't see a hatch on this side is because over here it's not completely closed. So there's an opening. And what I see on this surface is basically this surface right here. Or if you see the 3D view, it's that surface right there. But am I cutting through it? No. So I wouldn't be putting in a hatch. I just put in this edge which corresponds to this and this edge which corresponds to this. So it's important to make sure that you are not missing any object lines that you are not cutting through. Okay, a lot of people make that mistake, and that's where they get confused with the object lines and they forget putting those in. Now even if you put one line, if you forget to put one line, then your object is off. So you have to be careful, and it does take a little time to get used to the sectional views. So, but you practice a little bit and then you should be fine. Right? The next objective we have over here is section lining practices, techniques, and symbols. Now if you see over here, I put a sectional line. I just hashed it. So we have to see what are the different ways of hatching it, what is the correct way, what is the wrong way. So we are going to look into that right now. What are the different symbols for hatching? For example, if I'm hatching through concrete, I will have a different hatch design. If I'm cutting through brick, I'll have a different hatch design. If I'm cutting through wood, I'm gonna have a different hatch design or a symbol that you could see. So let's look at first some of the section lining techniques. First thing we need to do is, while we are making sections, is we have to draw the section lines correctly. Okay, so by default, if your object is in a shape like this, we have to draw the section lines at an angle, and that angle is usually 45 degrees. Second thing we have to remember is even these section lines are distant to each other. I cannot have one line drawn here and the other line drawn here. I have to make sure that all these lines are equidistant or at an equal distance. So this is one of the examples of correctly drawing sectional lines. Okay, now they have to be equidistant, like this distance should be – this distance between right there, right here, even though it looks a little different right now because I'm sketching, but they should be all equal distance. Okay, so that's one of the things. The second one is lines too close. So if I am trying to hatch this, I cannot have lines that are really too close to each other. Now what happens if I have lines that are really close to each other? Sometimes the line might overlap and it might look something like that. And that is wrong because why? You can misinterpret the drawing. So that's why we have to follow all these section lining techniques. So second one, you cannot have lines that are too close to each other. Okay? So don't do that. Not too close. It has to be at a certain distance. Now the third one is varying line widths. Okay, so what this means over here is I'm gonna draw a line. I'm gonna draw another one. Let's do it at a distance. I'm gonna draw a third one. I'm gonna draw a fourth one. Draw a fifth one. Sixth one. Seventh one. Now what's happening over here is these lines are at a varying distance or a varying width. Like this line is thick, this line is thin, then we have thick, thick, thin, thin, solid. So that causes confusion. The thick line might be confused to be an object line. Okay, now the fourth one we have to even keep in mind is when we are doing these hatchings, try to keep the hatch lines lighter than the object lines. Okay, like this is my object, or for example you see this object right here and you see the hatch lines over here. Both of them look like they are of the same thickness and they are of the same hardness. So a better option for this would be if I drew the line a little lighter. 1, 2, 3, 4, 5. See, that's a little dark, and now this thing kind of blends in with the object lines, right? Because this is the object line, this is my hatch line. So I have to try to keep my hatch lines a little lighter than the object line. Again, why? To avoid confusion. Okay, so I cannot have varying line widths. I cannot even have lines that are too thick. Okay, the next one is short hatch lines or overriding running lines. Okay, now what that means is, if you look in this example over here, I have lines that are not going all the way to the object. So that is a short hatch line, which is a no-no. You cannot have that. So all these lines need to go all the way up to the object. Okay, for example, I cannot have the lines going up till here, right? Or I cannot even have overrunning lines. I cannot start the hatch right there. Cannot have start the hatch right there and go like that. Some lines are inside, some lines are going outside. I cannot do that. So I have to make sure that when I am hatching my object, I cannot have my hatch lines that are short like this one, or they are running outside of my object like this one. So both of them are wrong. So the correct one should start at the object and end at the object. Okay, so now these are all the different section type of lines. The next thing we are going to see is more hatches on objects over here. Now, which are right and which are wrong. Okay, now you have this one example, two example, and the third example right here. Now, which of them, all these three, is the best or the correct way of hatching? Now, if I look in number 3, the hatching is going at an angle of 45, which is good. But what happens over here is even my object is going at an angle of 45. You see this? So if I am hatching in that direction, which is 45, then it confuses with my object line. See that? So my object line is kind of confusing and blending with my hatch line. Why? Because it is at the same angle. So even if I can do this, it is not a good practice. Now let's see number 2. In number 2, I have my hatch lines going in the direction of the object, which is 45 degrees. All these. So as far as I'm going from here, it looks good. But when I get up here, now this is the place where my hatch lines are blending in with my object lines. So which is again not a good thing or not a good practice. So even though you could do this, but this is not a good option. Why? Because over here the lines, the 90-degree lines, are not good. Over here the 45 are not good. So now what we have to do is find an angle which is different from this one or this one, and it shouldn't match any of the lines onto my object. So over here I have taken 60 degrees. Now this thing works the best because none of my object lines are going 60 degrees. So you see how important it is just to even get the right angle of your hatch. Now again, why are we doing all these things and all these techniques that you see over here? Is mainly to avoid confusion and mistakes. And we all know that one mistake could cost thousands of dollars on the site. Okay, so let's see what the next topic is. The next topic we have is the symbols for section lines. Okay, now let's look at some of the symbols that we have. Now if I were to cut into an object that is made out of steel, so instead of putting my hatch lines just like that in this object, now just imagine this object is made out of steel. So instead of putting hatch line just like that, I would use the symbol for steel. Now the symbol for steel is just like hatch line, but you have two lines closer to each other. So I'll have one, I'll have two. Then I can skip one of those lines, which is this one, and then I will have another two, which is one and two. Skip another one, have one and two, one and two, one and two. All of them have to be in the same direction, even though my lines might not be in the same angle or direction, but you should be having it in the same angle and the same direction. So this is a symbol for steel. For example, if we were to hatch I guess this object, and I knew that this was in steel, instead of hatching it just like that, I would hatch it like this. One, two, and why would I do this? The reason being, because this is a standard. Everyone in the world knows that this hatching pattern is used for steel. So he doesn't have to confuse this object to be like a wooden block. Okay, he knows it is steel. Why? Because you use the right hatch pattern, which is for steel. Now let's look into some others that you have over here. If you are cutting through the cork or leather, you'd be putting in this pattern. If you're cutting through concrete, you'd be putting in this. For example, if you're cutting through a foundation of a building, you will be using this pattern. Now let's see where we have that, and we have that right here. So over here, this is my foundation, or if you zoom in, this is my footing, and this pattern is for concrete or reinforced concrete. So just looking at that, I know that it's not brick, it is a concrete footing. So that's where it gets so important to use the right symbol for the right objects. Now we have sand, then we have wood. If we are cutting through wood, we are going to show just like the grains of the wood. It depends on what direction you're cutting. You're cutting from the top or the side. If you're cutting through the ground, like in a sectional view for a house, the ground is going to be hatched like that. For example, if you see, that's the hatch and that's the ground level. So you have to use all these standards while cutting through sections, and it's not a lot, it's just it depends on what industry you're working, and that's how you're going to have different types of symbols. If you're cutting through iron, it's going to look like that. If you're cutting through an object that has some liquid or water, it's going to look like this. So you can look it up. There are so many different patterns. For glass, you just be using some dashed lines on the glass that shows like it's reflecting, and that's pretty much about what I'm going to show in here. Now another standard or practice that we need to remember while sectioning objects is when it comes to dimension, we have three different options, which is 1, 2, and 3. In this one, which one is the correct or the most correct dimensioning and which one is not good? Okay, so in here, number 1 is the best, Why? Because the dimension should always be placed outside of the object so that it doesn't get confused with the hatch lines. Now the second one is okay only if your drawing is too filled up and you don't have place to put it on the outside of the object. So you are putting on the inside of the object that is hatched. But one thing you should remember is the hatch lines should not overlap the dimension. Now what happens if the hatch line is overlapping my dimension? What is that going to cause? What that could cause is a big mistake. So that 10 might look like 17 or 19, right? So someone might think that this hatch, instead of like that, is a 19, and they would manufacture that part with the thickness of 19. Now if something was thickness of 10 and 19, that's pretty much double the size. Double the size meaning double the cost. So that's why you have to be really clear and careful when you're doing any dimensioning on the inside of the hatch. You have to make sure that you erase the hatch around the dimension. Okay? The third one, this is a no-no. This is placed right on the hatch and this part is not erased. So this will cause confusion and mistakes on the site and cost us money. Okay, so when it comes to hatch and dimension, again, you have to follow this standard so you don't make a mistake. Okay, now what's the next topic we have here is, I believe, we have to draw sectional views given isometric view. So we already saw this one example and we saw this one example. Okay, now both of them, this one as well as this one, they are full sections. Even this one is a full section. Okay, what this means, I'm cutting it from one end to the other end pretty much through and through. If I am cutting just half of the object, like I'm going like that, then if I'm cutting just this much, then it will be called as a half section. Now we are going to get to there when we get to all the different types of sections you see over here: full section, half section, offset section, broken out, aligned, revolved, removed. Okay, and we are going to see all the examples that belong there. Okay, so before we get there, we are going to look into how we even draw the correct sections and the correct practices of having the sections, like the linings. So for example, we have this object over here, we've cut it from half. So this is like a, this is called as a 3D sectional view. Okay, and this one is called as a 2D sectional view. Now what's the difference between these two? Obviously this is in 3D and this is in 2D. The one in 3D is mostly used for explanation, trying to explain to the client how the object looks like when it's cut from the center. But when it comes to manufacturing, you will always have the 2D section view. Why? Because you're going to put in all the dimensions, the sizes, okay, all that is going to go in your orthographic view. It's not going to go on your 3D view. So over here we're going to talk about rules for lines. Okay, now you can visualize this object. It's like a cylinder with a hole and is resting on another round cylindrical base. Okay, so when I am cutting through here, you can already see the section lines. So what is the correct way of drawing this section? So now we have 1, 2, 3, 4, 5, and 6 different options. Now let's see from the top down which one is correct and why is it correct, or which one is wrong and why is it wrong. Now if you see the first one is the most correct and the only correct section view. Okay, why? Because what you see over here when you're cutting through this, the cylindrical base, okay, now you have to know this is a hollow right here. So that's why this whole section is not going all the way through and through, because it's in hollow. But we have another cylinder placed on it, which is right here. So that's what you see, this hatch. Okay, now even though I'm trying to explain as another cylinder, but it's still one object. So if you see, you're not going to have a line right there. Why? Because it's cutting through the same exact object, whatever the material is. So if this part was steel and that part was wood, then you would have different lines, because then there are two different textures involved. But what we have is just one object, so we are going to have the section go through and through all the way up till there. Now over here we have a gap, and this gap is for this hole that you see in your 3D view. And again we continue, again we start cutting through the object, which is like that, and going all the way down. Now what is this line? This is an elevational object line. So where can you find that line? Over here is the same one as this one. So a lot of people will forget that line, but even though you're cutting through an object, you're still seeing elevational object lines. So that's one of the lines that you see. This is the second one, and that's the third one. So 1, 2, 3. So if I have any one of these lines missing, then my object is not going to be correct. Okay, so this is the only correct section view that we have. Secondly, we are even showing the center line. Now the center line is because we are cutting through a circular object, a hole. Okay, now let's go to the next one. Now you tell me, why is this wrong? Now just looking at that, we can see that these visible lines are not shown. And if these visible lines are not shown, then that means it's wrong. So those visible lines are going to be there, or else your object looks like it's two different pieces and it's not even connected. So this line shows that it is connected. Okay, so see how important that those lines are. If not, then your section is going to be wrong, and someone is going to manufacture two different parts of that shape, which is crazy. So this is wrong. Now let's go to the third one. Third one, now this I talked in the beginning. This third one, what do you see here? I have got all my section lines which are like that. That is good. But over here what I'm showing is some hidden lines. Now those hidden lines are for what? Are for this one. You see this line, this goes all the way around. See, it goes all the way around right here. And even that thickness goes all the way around. So if I'm looking in this direction after I cut it, then I have hidden lines. But do I draw the hidden lines? No. Section views are drawn so that you omit the hidden lines. So if you're going to have any hidden lines in a sectional view, then it's a poor decision to draw those. Not like you will never see it. You will see it sometimes, but it's not a good decision to draw hidden lines. The next one, number 4, again you see some hidden lines. Now obviously this is wrong. Why? Because first of all, this should be a solid line. Why? Because when I'm cutting through it, I'm seeing that. So that's a solid line right there. It cannot have a hidden line. And secondly, the reason why it's wrong is because hatch lines is never bounded by hidden lines. It has to be always hatch lines, which is these hatch lines are always bounded by a solid line, never a hidden line. Okay, so that's wrong. Now we have 1 and 2 more left. Why is this wrong? This is tough to see, but if you look closely, the hatch for the same object, which is our object right here, the hatch lines for the object over here is going in this direction. By the time I get over here, the hatch direction has changed to an opposite direction. So what that means is this is a different object and this is a different object. Or for example, I had a hatch over here going like that and another hatch going like this. So then that means this is steel and this is something else. Okay, so you have to make sure that unless you have two different materials, you cannot put two different symbols. And secondly, if it's the same object, then the hatch direction should be the same. Okay, now let's go to the last one. Now why is this one wrong? The reason why this one is wrong, because a hatch on a single part is never crossed by a visible line. So over here you have a hatch, right? And it's one object. This whole thing is one object. And if it is if you have a solid line there and here, then that doesn't mean that it's one object. That means there are two different objects. So if I had two different hatches, then it would be a different story. Then it would be okay. But then I could have that line there. But the thing is, I have just the same object, same material. So I cannot have two different hatches, or I cannot have the solid line because the same hatch is not going to be crossed by a visible line.